Hello, calculus fans. Okay, so now let's do some calculus. We're now ready to compute the derivative of the inverse sine function. And before we do that, I just want to talk a little bit more about inverse functions because this will be relevant for our computation of the derivative of inverse sine. Now we already know a little bit about exponentials and log functions, so we have a cancellation property. So for instance, log of e to the x is equal to x for all real x, and e to the log x is equal to x, at least when x is positive. Why the difference? Well, the domain of the log function is only positive real numbers, whereas the domain of the exponential is all real numbers. So it just has to do with the domains of these functions. So we've created an inverse function to the sine function. Well, that's not exactly right. We created an inverse for a restricted version of the sine function, so that gives us a new cancellation property. Analogous to the log and the exponential, we now can say that the inverse sine of sine is equal to x. But now this is only good between minus pi over 2 and pi over 2 because we've restricted the domain of the sine function. And similarly, the sine of the inverse sine of x is equal to x. But that's only good between minus 1 and 1 because that's the domain of the inverse sine function. Now this cancellation property, this is going to be important to be able to compute the derivative of the inverse sine function. Okay, we're ready to do that now. So we're going to demonstrate how to compute the derivative of the inverse sine. So we'll start by just calling y arcsine of x. And then the cancellation properties we just showed tell us that sine of y is equal to x. Now our goal is to find y prime, so let's take this equation here and use implicit differentiation to determine y prime. Okay, so keep in mind what we're doing here. We're taking this equation, we're going to differentiate implicitly. That is, we're going to take the derivative of both sides with respect to x. So if we do that, then we wind up with cosine of y times y prime equals 1. So on the left-hand side of the equation, we're using the chain rule. So the derivative of sine of y is cosine of y, and then we have to multiply by y prime for the chain rule. Okay, so if we solve for y prime, then we end up with this. Y prime is equal to 1 over cosine of y. Now you could rewrite this as secant if you wanted to, but I'd like to leave it like this just for now. Now, we'll keep in mind that the value of y is between negative pi over 2 and pi over 2. That tells us that the value of cosine is positive. So if you're saying that the value of y is between negative pi over 2 and pi over 2, so that says you're dealing with a first or a fourth quadrant angle. And in the first or the fourth quadrant, the cosine is always positive. Now let's play around with the Pythagorean identity a little bit. This Pythagorean identity is really ubiquitous. It shows up everywhere. It does a lot of stuff for us. All right, so here's the Pythagorean identity. I'd like to solve for cosine of y. So we move the sine squared over to the right side. Now we're going to take a square root. So we get cosine of y is equal to the square root of 1 minus sine squared of y. Now ordinarily, one should have a plus or minus in front of this. However, we've determined that cosine has to be bigger than 0. So I don't want a plus or minus on this. We're just going to keep it as a positive root. Now we go back to our expression for y prime that we had computed. So up here we had calculated that y prime is equal to 1 over cosine of y. So let's take that now and plug in this value of cosine of y that we got from the Pythagorean identity. So we get 1 over the square root of 1 minus sine squared y. And then the last piece of information that we're going to use is this here, that sine of y is equal to x. So we can just go ahead and put that into this expression here, and let's see what we get. By making that replacement, we just get 1 over the square root of 1 minus x squared. That's it. That's the thing that we wanted to calculate. The derivative of the arcsine function is 1 over the square root of 1 minus x squared. Okay, that's all for now.